Okay, so if we're looking for how many moles, what part of the mole equation is it asking me to solve for? N, right. Okay, so N is our question mark. Okay, they tell us that this is calcium carbonate, which will help me get my molar mass. So that'll be 40.08, that's my calcium, plus 1 carbon, 12.01, plus 3 oxygens, 16 times 3, 52.09 plus 48, 100.09. Am I right? Okay. All right, so then we've got that, and they also tell us that it's 125 grams. Okay, so we would get 1 mark, okay, for writing down our givens and calculating the molar mass. We're being asked to calculate the number of moles, which is N, okay, which is little m divided by big M. I have both of those numbers, so all I have to do is plug them in. 125 grams divided by 100.09 grams per mole. So the grams are going to cancel, and I'm going to be left with moles, and it'll be 1.25, I believe. Moles. Okay, everybody all right with that? Okay. So for question number 2, they're asking, what is the mass? So what part of the mole equation am I looking for? Little m, right. Okay, so I'm looking for little m. They tell me I have 2.7 moles. So they gave me N. Okay, and they tell me that it is lithium phosphide. So that'll be 6.94 times 3. Okay, won't be doing that one in my head. Plus 30.97, our 1 phosphorus there. Okay, so 6.94 times 3 plus 30.97. Whoop. What's that number? Okay, it gives me 51.79 grams per mole. Okay, so 1 mark for our givens. Now on this one, we have to solve for little m. So what do I do with big M to get little m by itself? I times it. I multiply both sides by it. So if I multiply this side by it, it cancels. Then I multiply this side by it, and now I've got my formula. Okay, so you get a mark for plugging in your numbers here. So that'll be 51.79, big M, times 2.7. So this is in grams per mole, and this is in moles. So the moles will cancel when we do that multiplication, and we'll be left with grams. So we take our 51.79, and we multiply it by 2.7, and we get 139.83. What are my units? Grams. Okay, questions on number 2? Okay, how many people are still working on 3 and 4? Okay, what's the magic number you need for 3 and 4? Avogadro's number. Right, you need that 6.02 that I wrote on the first page here. Okay, what does this number tell me again? Right, number of molecules in a mole if I'm talking about a compound, number of atoms in a mole if I'm talking about a single element, okay? But it is, okay, we'll just say molecules per mole because that's most often what we use it for, okay? Molecules per mole, okay? You are only going to do one of 2 things with that number. You are either going to multiply by it or divide by it. That's it. You won't use it in any other way. So what you have to do is ask yourself, when do I need to multiply by this number? And when do I need to divide by this number? Okay? If I multiply by this number, will I get a really big number? I will. Okay? So that's probably what I would want to do if I'm looking for something that would be a really big number, like number of molecules. Okay? Conversely, if I'm trying to find mass, which means I would need moles, is moles usually a small number? It is. So if I want to get a small number, look at this one here, I'm given a big number here. I would probably want to divide those numbers so I get a smaller number. Okay? Think about what kind of number you want and what mathematical operation will help you get it, and that's going to help you figure out what to do with that one. Okay, give you a few more minutes on 3 and 4 there. All right, let's look at 3 and 4. All right, so in number 3, I'm looking for the number of molecules. Okay, they tell me that it's iron 3 oxide. What can I get with that? Big M. Yeah, I can get the molar mass. All right, so if it's iron 3 oxide, I'm going to have 2 irons, 58.85 times 2, plus 3 oxygens, 16 times 3. Okay, so 55.85 times 2 plus 16 times 3, and he's going to give me 159.7 grams per mole. Okay. And they tell me I have 230 grams, which is little m. Okay, so they want the number of molecules. If I'm going to get the number of molecules, okay, and I have Avogadro's number, which is molecules per mole, what other number do I need? N. Yeah, I need the number of moles. Okay, and I can get that right now because I have little m and big M. So that's my next step. Okay, N equals little m over big M. Remember that you would get a mark for your givens here. Okay, you would get a mark for this step because it involves you plugging in some numbers. So that'll be 230 grams divided by 159.7 grams per mole. The grams are going to cancel. So 230 divided by that number gives us 1.44. Now, I'm going to keep all of my decimals. I'm not going to write them all on the board, but I'm going to keep them because I'm about to multiply by a gargantuan number. And rounding those numbers off is going to significantly change what I would get. So you always, doesn't matter what you're doing in science, you always keep all your decimals until the very end, and you round only your final answer. Okay, so I'm going to take that number there, okay, and say that I've got my 1.44 moles. Okay, and as we just said, I want to get a big number. Number of molecules is going to be a big number. So I'm going to take the number of moles, and I'm going to multiply it by Avogadro's number. So I'm going to take the number of molecules, it's going to be N times Av's number. Okay, which is going to be 1.44 with all the decimals that are in my calculator, moles, times 6.02 times 10 to the 23 molecules per mole. Okay, when I do that, the moles are going to cancel, and I'm going to be left with molecules. Okay, and it's going to be a big number. So I'm going to take that number there, and I'm going to multiply it by, in brackets, 6.02 E23. Not divide, I'm going to multiply. Why did I have a divide number? Okay, times, that's better. Okay, so I do get a big number. I should get a big number. I'm talking about the number of tiny little particles. Okay, 8.67 times 10 to the 23. All right, so my final answer here would be 8.67 times 10 to the 23. What are my units? Molecules. Okay, that's a type 3 question. Are we ready to go over the type 4 question? All right, so in this one, they give me the number of molecules. Okay, so I'm told that I have 5.42 times 10 to the 21 molecules. Now, is that more or less than a mole? Less. A lot less. Okay, a mole is 6.02 times 10 to the 23. This is only times 10 to the 21. That's 2 factors of 10 smaller. That's 100 times smaller. Okay, so whatever number we're going to get here is going to be hundreds of times smaller than a mole. In other words, what kind of number am I going to get? A decimal, a really small one. Okay? It's always good to kind of run that through your head a little bit before you do the math, so you have some idea of when you punch all your stuff into the calculator if you got something right. Okay? So we got the number of molecules. Okay? We know that that we're looking for mass. Okay? And that we know the material is nickel 2 nitrate. Now, this is a trickier one to do molar mass on. I probably would give you an easier compound on the test for a type 4 question. But that's exactly the kind of compound I would give you on a type 1 question. Okay? Because on a type 1 question, the math is easy. I would give you a harder compound. Okay? All right, so for this one here, how many nickel do I have? 1, 59.64, right? Is that right? For nickel? I should probably think it's 69. That's close. Okay. It's 59.69, right? Yeah, it's 58.69. Okay, I wasn't close enough. I don't have the periodic table memorized. Okay, 1 nickel. How many nitrogens do I have? 2. Okay, so 14.01. Okay, times 2. How many oxygens do I have? 6. All right, so we put all those together, 58.69 plus 28.02, that's my 2 nitrogens, plus 16 times 6, like 96. Okay, 182.71. Grams per mole. Okay, so that would be our first mark. That's our givens. If I'm going to get little m, what do I need? N. Okay, don't have it right now, but I have this many molecules, and Avogadro's number tells me how many molecules are in a mole, and we just discussed that that number is very small and means that I have far less than 1 mole. How did we figure that out? What mathematical operation did I do with those 2 numbers? I said that that number was hundreds of times smaller than Avogadro's number. I know that because I took that number and did what with Avogadro's number? Divided by it. Yeah, that's how you get small numbers, right? I took 2 huge numbers and I divided them and I got a really, really small number. Okay? Moles is going to be a small number compared to that. Okay? So N is going to be the number of molecules, okay, divided by as numbered. Okay, so that's going to be 5.42 times 10 to the 21 divided by 6, I'm sorry, that's the molecules. Okay, divided by 6.02 times 10 to the 23 molecules per mole. So when I do that, the molecules will cancel. I'll be left with moles, and I'll be left with a very, very small number. Okay, so 5.42, okay, E21 divided by 6.02 E23. Okay, is that a small number? Is that hundreds of times smaller than a mole? According to my math, that's 9 1,000ths of a mole. Okay, that's pretty small. Okay, so yeah, 0.009 moles. Now, I'm going to keep all those decimals in my calculator. I'm just not going to write them all. Okay, now I know N. Can I get little m? Okay, so 1 mark for that. You would get 1 mark for this operation, calculating the number of moles. Okay, then you would have N equals little m over big M. What do I have to do to get little m by itself? Multiply by big M. Okay, so that's going to mean 182.71 grams per mole, okay, multiplied by 0.009 moles. When I do that, the moles are going to cancel, and I'll be left with grams. Okay, and it's going to be a pretty small number. Okay, so I'm going to take that number there, and I'm going to multiply it by that number there. Okay, now I can round off. It's my final answer, 1.64 grams. Okay, so I'd get a mark for the manipulation here, okay, and a mark for that. So we'd be looking at 4 marks, maybe, actually, sorry, 5 marks because you get a mark for your manipulation. Okay? All right, questions on any of those? All right, on your test, that's the kind of question you're going to get, except I'm going to give you the name of the material, not the formula for it. Okay, that's all that's going to change. Now, we do need to be able to do mole equation problems that are not stated as simply as these. Okay, when I give you these kinds of questions, they're very simplistic. Okay, and I don't mean that they're simple or easy to do. I mean that the questions are, do this calculation. This is a type 1 question. Do this calculation. It's a type 2 question. You can tell right away because there's no context. There's no story in the question. What we want to build up in your skills or in your repertoire of skills, okay, as you go forward in science, is your ability to read questions that have context. Okay? Because what a lot of times questions will do is they'll roll in a bunch of other stuff that's kind of extraneous, that means not necessary or extra, okay, and try and confuse you with it. All right? So a question will be like a story. This is going on and this is happening. You have this much of this stuff and blah, 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 a bunch of other, minutia and other details that aren't important. And now solve this. Okay? So we need to be able to read through a question like that. And it's almost like reading comp in English. I've got to be able to go through this question and decide this is important and this is important. There's no symbolism or anything like that. Okay? So you don't have to worry about interpreting, but it's what can I get from this question? Okay? The reason we do that is by the time you get to a diploma exam, and it doesn't matter what science it is, by the time you get to a diploma exam in grade 12, there are situations where you can be reading an entire page of text to answer one question. Okay? It happens quite a bit in biology. You get a lot of reading in biology, but it's also happening in physics. We saw on a diploma exam 2 years ago, that exact situation I just described to you. An entire page of text talking about a cathode ray tube, and then they had to use all of that entire page. There were only like 3 pieces of information that were important, and they had to solve a numerical response question with it. Okay? It was a difficult question simply because people got lost in the details. All right, so we're kind of trying to train you towards that thing. Okay, so on that note, here are some questions that involve not so much a whole page of text, but we're kind of building towards that. Okay, so if we're looking at question number 1, we'll kind of walk through this one as an example. Okay, in question number 1, it says, in the metallurgy of iron, metallurgy is taking the ore and then converting it into the useful metal. That's what metallurgy is. Okay, the iron ore, iron 3 oxide, is converted to iron and carbon monoxide by reacting the ore with coke, that's pure carbon. How many grams of iron 3 oxide are in 0.580 moles? Okay. How many pieces of information are in that story that are important?
Do you have to predict it first and then use the information that you get?
No, but that's what they want you to think, right? Because they're talking about a chemical reaction. They're getting you to think about what type of reaction is going on here. We haven't done any mole stuff to do with reactions, but that's what they want you to do. They're spinning this yarn to get you lost. Okay? In this yarn, what are they asking me to solve for?
How many grams?
Right, which would be
Little f.
little m. They want me to solve for mass. Okay, this question is about solving for the mass of something. Okay, so I know in this question, mass is unknown. Sorry, was that what you're going to ask too? Can you guys wait till I'm done this one and then go? Okay. All right, so I'm being asked to find mass. Did they tell me what material they want me to find the mass of? Yeah, right here in the last sentence. How many grams of iron 3 oxide are in 0.580 moles? Is that another important piece of information? That's the what? That's N, yeah. Okay, so they told me N, 0.580 moles, and they told me that the stuff is Fe2O3, so I can get big N. But they spun this yarn to confuse me before I got to that point. Now that I see, that's not too bad. That's a type 2 question. Yeah. Okay, don't even need Avogadro's number for that. But they try and throw you off with a bunch of unimportant details about metallurgy and coke and all this other stuff that is not part of the question. Okay? All right, kids can go. Both of you can go. Okay, so let's have you guys try 1, 2, 3, and 4. Sorry, 1, 2, 3, and 5. Don't worry about number 4 for right now. Okay? I'll scroll up so you can see the rest of 5 here in a minute. So you guys can finish number 1 and then work on and 5. The answers are what's in bold there. This is also in your digital workbook, so if you're having trouble reading it up here, you can bring it up on your phone. Okay, it's in the digital workbook. Okay, so in number 5, the thing that number 5 is trying to do is confuse you about which material you're supposed to be calculating this about. Okay, it mentions 2 things, but then it only tells you information about one of them. So it says, a student made the following observations in an experiment where a strip of copper was placed in an aqueous solution of silver nitrate. So somebody just dropped a piece of copper into a solution of silver nitrate. Okay? Initial mass of the copper strip, 2.97 grams. Is that the mass of the silver nitrate or the copper? Copper. Okay? That's what it's trying to confuse you with. Okay, it's telling you here's the mass of the copper. Okay, and then it says how many moles is this? So if I know the mass of copper, do I also know the molar mass of copper? It's on my periodic table. I just have to go over here and look up copper and see that it's 63.55 grams per mole. Okay, so I take 2.97, I divide it by that, and I've got my number of moles. Okay, the real hint in this question is that the second part of it asks how many atoms. Only copper comes as atoms. Silver nitrate is a compound, so its smallest particle is a molecule. It would have asked you for the number of molecules if it was asking about silver nitrate. You see how these context questions can try and trick you? Okay? You really have to look at the wording and apply it to what's in that question. As soon as you see atoms, you know you have to be dealing with an element. Okay? A compound would never ask for atoms, it would always ask for molecules. Okay? It's little tricks like that that they're trying to pull, okay, to try and confuse you. Now again, on your unit exam, I am not going to do this, okay? But you need to get used to reading through a question and getting what you need from it, even if it's a convoluted story. Okay? All right, any other ones that are giving us trouble, guys? Number 6? Okay, so similar thing. In number 6, they're talking about this reaction that you use to clean iron off of rusty steel surfaces. Okay, the reaction is this whole equation. This whole equation, totally pointless. Just there to throw you off. Okay, what's the mass of rust? So this is rust, FeOH3. Okay, so what is the mass of rust in 0.6 moles of iron hydroxide, iron 2 hydroxide? So in this question, they told me N is 0.600 moles, and they told me the material, iron, that's why that would be confused. It's supposed to be a 3 here, guys, FeOH3. So it would be 55.85, okay, plus 16 times 3 plus 1.01 times 3, and then you would go from there. It's my mistake. I put a 2 here when that should have been a 3, because I had 3 up here. Okay? All right. again, none of these guys are beyond what we did as types, as question types. They're just throwing in a lot of information and Codere screwing up and putting in the wrong number to confuse you. Okay? All right, so tomorrow, quiz will look just like the questions we did at the beginning, 4 types basic, okay, like that. And then we'll work on some more mole stuff tomorrow, and then we'll see how it goes. We might start Unit 2 on Wednesday, okay? And then your exam will be Thursday. Yes, it's in your digital workbook for review.